So last up for this worksheet, chapter, entire unit on rational stuff, we're going to talk about inverse variation. And this is the reason why we lump variation with rational stuff. So first of all, we have a definition. If a situation is described by an equation in the form y equals k divided by x, where k is a constant, we say that y varies inversely as x or y is inversely proportional to x, and we call the number k the constant of variation. Now, what you need to understand about this that is very different from direct variation. With direct variation, if x got bigger, y got bigger. If y got smaller, x got smaller. So as one variable changed, the other one changed proportionally to that, okay? With inverse variation, it's kind of the flip-flop. So as x gets bigger, y gets smaller. As x gets smaller, y gets bigger. So these variables change inversely. So as one is getting bigger, the other is getting smaller and vice versa. So this is very different from direct variation in what's going on behind the scenes, but the setup and the steps to solve are basically identical. So you just have to remember this right here. If you're dealing with inverse variation, y equals k divided by x, not multiplied by x, okay? So understand the different formula for direct variation compared to inverse variation. Now let's look at an example. Our first example is just going to be really basic with just plain old numbers. Then we'll look at an application. So for example 3, it says, suppose that y varies inversely with x when x is 3, y is 15. Find y if x is 5. So we first want to find, for part A, we want to find k, the constant of variation. Well, we know that if y varies inversely with x, we have a situation like y equals k over x. And then we're told without a shadow of a doubt, we have to know that y is 15 when x is 3. We're given that, we're told that, we know that, okay? So we're going to use that to figure out what k is. Well, we know that if y is 15 when x is 3, we can set that up in this equation right here and just solve for k. So in order to solve for k, I want to multiply both sides of this equation by the LCD. So the LCD here is 3. So I'm going to multiply right and left by 3. Well, 3 times 15 is just 45. And then k over 3 times 3, what happens here is this 3 right here in the denominator, let me change colors. So this 3 in the denominator divides into the LCD one time. So we're just left with 1 times k, or k. So now we know that k equals 45. So then part B says, okay, you know what k is. Now write an equation that relates x and y. So I would get y equals 45 over x. That is our new equation. Okay, and then part C says find the quantity indicated. Well, the quantity indicated is find y if x is 5. So we have y equals 45 over x, but x equals 5. So I'm going to replace x with 5. So y equals 45 over 5. So y is equal to 9. So those just basic problems like this are pretty easy to solve. You just need to be very careful. Are you dealing with direct or inverse variation? You've got to remember those two formulas. First step, you have to find k, rewrite the equation or the formula, plugging in a value for k, and then you can use that to solve a number of different questions or find a number of different variables or indicated values. Okay, last up is example 4. So this has been a very long chapter, a generally somewhat difficult chapter, but I think we're ending on an easy note. So this is the last example. It says the time t it takes to get to work varies inversely with your average speed. That should kind of make sense. If you speed up, you're going faster, your time decreases. If you slow down, your time increases. So again, as one thing gets bigger, the other one gets smaller, okay? So we have time t varies inversely with your average speed s. So what we have so far is t equals k over s. Okay. Now suppose it takes 30 minutes to drive to work if your speed is 35. So we're being told, okay, t is 30 and s is 35. Find k. So we're going to plug in what we know. We know 30 equals k over 35. We need to solve for k, so we've got an LCD. of 35 here. We want to multiply both sides of this equation by 35. Well, on the right-hand side, 35 in the denominator divides into 35 in the LCD once, leaving me with just a K. And then the left-hand side, I have 30 times 35. And if you can't do that in your head, that's fine. Grab a calculator. So we have 30 times 35, which is 1,050. So 35 times 30 is 1,050. That is our constant of variation. So for part B, it says write an equation that relates T and S. Well, we know T equals K over S, but we now know K is 1,050. So T equals 1,050 over S. So there's our equation. That's the equation that's going to relate the two variables. And then finally, to the nearest minute, how long would it take you to get to work if your average speed was 45 miles per hour? So we know T equals 1,050 over S, but S is 45. So we're going to plug S into this equation and then solve. So T equals 1,050 divided by 45. Let's go back to the calculator. So we're going to take our 1,050, we're going to divide it by 45, and we get 23.33333. So T equals 23.3 repeating minutes to get to work, but answer the question in the right format. It says to the nearest minute. If I were going to round 23.3 to the nearest ones place, I would say T is approximately 23 minutes. So again, as my speed increased, I went from 35 miles an hour to 45 miles per hour. So my speed increased, my time to get to work decreased. It went from 30 minutes down to 23 minutes. So hopefully you can kind of see how inverse variation works. Again, direct variation, as one variable gets bigger, so does the other one. Inverse variation, as one variable gets bigger, the other one gets smaller. Okay, so that's the final example in our quest to learn rational equations and expressions. So I think it's ending on an easy note. Variation's not too bad. Just know that when you get to a pre-calculus class, you'll expand on this idea for sure.